To add fractions, we have to make sure they have a common denominator, so I'm going to change 3/2 to 9/6, and then we can add them. We get 7/6 plus 9/6 is 15/6, but that's not done because we have to simplify it further, and that can simplify down to 5/2. So for this one, we have to do the same thing, except there's no common factor, so we have to change both denominators. And the lowest common factor is just multiplying them to get 15. So now that we've got that, we've got 10/15 and 12/15. 10 minus 12 is -2, so we have -2/15. 1/2 times 6/7. You can multiply this out and you get 6/14. You can also think of it as half of 6/7 is 3/7. 2/5 divided by 15/2. So when you divide fractions, you just flip one and then you multiply them. So let's see. First, we want to do the x plus 2 squared because it's in parentheses. So that's the first order of operation, and then we can plug in x squared plus 4x plus 4 back into the equation. Since it's -3, we have to make sure we apply that negative to all three terms in that parentheses, so it's -3x squared minus 12x minus 12, and then when we add the 4x to that, we get -3x squared minus ax minus 12. Similarly, on this next problem, we want to do the parentheses first, so we get 3 minus 8 is -5. So then we get 5 minus 6 times 4 is 24, 7 cubed is 343, minus 325, that equals 299. So now we're going to use the vertical line test to test these graphs to see if they're functions. So we can just draw a couple vertical lines down and see if we hit twice. That's the rule. So this one's only hitting once no matter where we draw it, so it is a function. This one, it only hits once there, but it hits twice there, we can see, so that's not a function. Let's see, this one looks like it's a function. And this one is definitely not a function because it hits twice. Now we're looking at composition of functions. So we know what f of x is, so we can just know what f of 4 is by plugging 4 in for x. So f of 4 equals 4 squared plus 3 times 4 plus 5. And then we're going to get 16 plus 12 plus 5 equals 33. So g of a, we're just plugging in a for x in this one, so it's literally just going to be the same function, but with an a instead of an x. F of h plus 2, that means we're plugging in h plus 2 for every x. So that means we have h plus 2 squared plus 3 times h plus 2 plus 5. So then we want to do h plus 2 first, which is going to be h squared plus 4h plus 4 by foiling, and then you get plus 3h, distribute that 3 plus 6 plus 5, and then you're just going to combine all like terms. So you get h squared plus 7h plus 15. And then now if g of x equals f of x, then we can just set these two functions equal to each other, and then start balancing the equation. Minus 3x minus 3x. And we get 14 equals x squared plus 5. When you have an x squared, you know you're going to have to set one side equal to 0 in order to solve it. So we get x squared minus 9. That's a difference of squares. That means we have x plus 3 times x minus 3 is going to be x. And then so x is going to equal 3 and -3. So now we're just solving for x. This is going to be some like balancing equations. So minus 3, x equals 3. Let's see, on this one we've got -4, so 3/8 x equals 3. So then you just multiply both sides by 8/3, so we can cancel that 3/8 out. And 3 times 8 is 24, divided by 3 is 8. This one we have minus x, so then we get 2 equals x plus 4, and x equals -2. So this one we have parentheses with multipliers outside, so we need to distribute 4y plus 4 equals 2y plus 4. Immediately that seems a little fishy, and that's going to tell us if 4y equals 2y, then y is going to have to equal 0, because that's the only time that could possibly be true. So we got 3x squared minus x cubed plus y minus x squared minus 5x cubed plus 2y, because we have to distribute the negative. So now we're just going to combine like terms. 2x squared minus 6x cubed plus 3y. On this one, there are two ways to do this. You can write it out like this, and when you have x cubed times x cubed, you would add the exponents, or you can look at the original equation and see x cubed squared, you would multiply, so you get x to the 6th. So now we're just going to FOIL this one. X plus 2 times x plus 2, you want to multiply the first terms, and then the outer terms, and then the inner terms, and then the last terms. So that gives us x squared plus 2x plus 2x plus 4. And we can combine the 2x's into 4x. So we get x squared plus 4x plus 4. This is the same thing. So we're going to do x squared plus or minus 4x plus 3x minus 12. And then you just combine the middle terms, x squared minus x minus 12. So finding the x and y intercepts in the quadratic equations. So the x-intercept is when y equals 0, when we're right on the y-axis. So we're going to set y equal to 0, and then just solve that equation. 2/3 x equals 6, so that multiply both sides by 3/2 to get rid of that fraction, and you get x equals 18 divided by 2, which is 9. So our x-intercept is at x equals 9. So it's going to be 9 comma 0 is going to be the point. And then to find the y-intercept, we set x equal to 0. And that's a little easier because 2/3 times 0 is 0. Therefore, y equals -6. And then our point is going to be 0 comma -6. Okay, similarly, we see it's x squared, so that means we're going to have to factor it. And also this tells us there's going to be 2 x-intercepts. So you have x minus 2 times x plus 2 is equal to y, and then we can say that the y-intercept is at when x equals 0. So then y equals 0 minus 2 times 0 plus 2, that's -4. And you can see that from the original equation before we factored it a little easier probably. The x-intercept is when y equals 0, so we're going to set 0 equal to x minus 2 times x plus 2, and then you get 2 and -2. And so those points are going to be 2, 0, and -2, 0. And the y-intercept is 0, -4. And then now we're factoring, so we're just going to pull out any common terms that we can divide both things by. So we divide 20 and 15, they're both divisible by 5. ABC is divisible by A and C as well as A squared C. So you pull that out, and then what you're left with is 4B plus 3A. And then you got x squared plus 5x plus 6. So then we're going to factor this using our box and diamond method, and that's just going to be x plus 3 times x plus 2. So now we just got to draw a rough sketch. Quadratic is just a parabola. We learned that a long time ago. A cubic, when you have a negative number cubed, it becomes negative. It doesn't go back up like a parabola would. Exponentials go up real fast. And when a number to the power of 0, it's usually 1. It could be multiplied by something and be higher, so it's off the axis. And then square roots kind of level out flat, and they can't be negative. They have to start at 0. I'm not going to go over the Sudoku. I'll let you have fun with that.